Hello everyone, myself Aditya Ghatia and here I will discuss about my presentation topic ADA first internal solution. So in this series first I will discuss the question one by one. So the first question is complete the table 1.0 after the simplification of a corresponding recurrence relation. Here we have given the algorithm one by one and we have to find time complexity, space complexity and power complexity of this algorithm. Here the relation is also given in Tn form. So first we will discuss the time complexity. Time complexity may be depend on various factors such as a specific input input to the algorithm, efficiency of implementation, and use of any auxiliary data structure of or algorithm. In practice, the actual running time of algorithm may also be affected by various external factors such as hardware limitation, operating system overhead, and the size of input data. Here we will discuss a linear search time complexity is ON. Binary search time complexity is log n. Factorial time complexity is ON. Tower of Hanoi time complexity is 2 की power n. Binary search tree traversal time complexity is ON. Merge source time complexity is n log n. Quick sort time complexity is n log n. Quick sort worst case time complexity is O n square. Stars and matrix multiplication time complexity is n log 2 की power 7. Cartouche by integer multiplication time complexity is O n log 2 की power 3. Now, space complexity. Space complexity may be defined on other factors such as implementation detail, specific input to the algorithm. In some cases, the space complexity may also be affected by use of auxiliary data structure or temporary variable. Here, we will discuss the space complexity one by one. Linear search space complexity is O1. Binary search space complexity is O1. Factorial search space complexity is O1. For Tower of Hanoi, space complexity is ON. Binary search is traversal space complexity is OH, where H is the height of tree. Merge sort space complexity is ON. Then quick sort best case space complexity is O log n. Quick sort worst case space complexity is ON. Stars and matrix space complexity is ON square. Card suba integer multiplication space complexity is ON log 2 की power 3. Now we will discuss the time complexity, space complexity, power complexity, or power complexity. The power complexity of algorithm is measure of how the algorithm running time grow as input size increase. It is the typically increase expressed in a term of exponent in running time big omega notation. Note that the power complexity of algorithm are not the same as their time or space complexity. The time and space complexity may have different constant or lower order term that affect the actual running time or memory usage of the algorithm. Here the power complexity of a linear search is O(n). Binary search power complexity is O log n. Factorial power complexity is power O(n). Tower of Hanoi is O 2 की power n. Binary search tree levels time complexity is O(n). Merge sort time power complexity is O(n) log n. Quick sort best case time complexity is O log n. Quick sort worst case time complexity is O n square. Stars and matrix multiplication time complexity is O n log 2 की power 7. Karatsuba integer multiplication time complexity is O n log 2 की power 3. Now, second question is defined as write recursive algorithm for polynomial representation. The recursive polynomial algorithm is method for computing the coefficient of the polynomial given its root. The algorithm works by recursively factoring the polynomial into a smaller polynomial until each factor is a linear polynomial. The coefficient of original polynomial can then be computed by multiplying the linear factor together. The algorithm works by breaking down the problem of evaluating the polynomial of degree n into the problem of evaluating a polynomial of degree n minus 1. It uses the fact that polynomial of degree n can be expressed as for p x x into qx plus c, where qx is a polynomial of degree n minus 1 and c is the highest degree coefficient. This is allows that The evolution to perform the recursively by computing qx and multiplying by x and then adding the highest degree coefficient. The class polynomial is defined as here the algorithm for polynomial recursive approach is defined as given here. Now we will discuss question third. Write the iterative version of Tower of Honey. The implementation use a stack to keep a track of recursive call that would be made in recursive version. The stack start with the initial call to move n disk from road to road using the auxiliary road as an intermediary. In each iteration of loop, the top call is popped from the stack and executed. If there is only one disk to move, it move and the loop continues. Otherwise, two recursive call are pushed onto the stack. One to move n minus one disk from road to auxiliary road using road as an intermediary, and another to move n minus one disk from auxiliary road to road using from road to as intermediary. Finally, the call to move the remaining disk from road to be road is pushed on the stack. So the thank you.